So for those people that don't know me, my name is Simon Lightfoot. I set up the Flutter community with some of the other people from the general community. And I'm also CTO at Dev Angels London, a small development firm in the UK in London. This whole topic came around from a recent project we were working on. And I decided to solve the problems we were having, we needed to build our own real-time communication framework. It will be open sourced and you will get some links at the end, but it's not ready just yet. So just gonna preface that. So I trust most of you thinking, I know that's a great idea, but why would you really want to do that? Lots of yak shaving, redoing the wheel. It's already been done by Firebase. So those tools are great, but in the use cases that we had, we found there was limitations to those platforms, and they were just too overwhelming, and the workarounds were just too detrimental to the project. So I wanted to explore some of that together with you guys here on the stage today. So yeah, don't get me wrong, Firebase and Firestore are a great combination, and especially for Flutter projects, it's easy to just get going, started really quickly, and make use of the benefits of having that pre-made infrastructure that Google supply. But we had some issues, and I want to go through those now. So pros and cons of using Firebase and Firestore. It's easily deployable cloud functions. I mean, that's a good starting point. Downside, which is the big downside for me personally, was I couldn't write them in Dart, and also that meant that we couldn't have code reuse from the back end and the front end. I want to do a little hands up experiment here. Hands up, how many of you that have done cloud functions? Keep your hand up if you use TypeScript. Would you like to use Dart? Right, okay, that's what we want, right? Okay, so we're all on the same page, and hopefully this is going to get somewhere near close to that. So, pro to using Firebase, no need to create your own client libraries. Bad thing, it requires the native libraries, right? So this means that you are limited to those native platforms that Firebase supports. Mobile platforms, fine. Web, fine. Desktop, not so fine. So when you really want to make something that's cross-platform in Flutter, you're kind of stuck when you're trying to use Firebase and Firestore. There are things you can do, but all of it is not first-party solution, which means you lack support. There's a lot more effort you need to do. And what you're essentially doing is rebuilding those client libraries for desktop. And there's been a couple of community efforts to that effect. One of the benefits to Firebase and Firestore, which is the pro that took me to Firebase and Firestore at the very beginning, was the real-time database, now Firestore, obviously. For those that weren't around at the time, you had RESTful APIs and you had to keep re-requesting the data. And suddenly you have this notion of, I just change the data in the database and it gets delivered to me on my app and just instantly changes the screen. That was revolutionary at the time. And I think Firestore with Firebase has really pushed that forward. Anyway, but yeah, it's not really designed for event-based systems. So if you've got some data that you're trying to send back and forth to control or to update certain things, you're trying to do that with Firestore. Well, you can make a collection, you can make an events collection, and then you can put documents into that collection, and when it changes, you get the events. However, what you're really doing is working around the limitations of the platform. All right, and it's got hosted infrastructure, right? So that's brilliant. You didn't have to do anything. Firebase, deploy, done, Limitations, of course, you're bound by the limitations of the Firebase platform itself and their expectation of use, which kind of goes over some of the topics I just mentioned, but this notion that there are limitations, how many reads or writes you can do concurrently per second on different documents and limitations as such. And then deployments. So I said deployments just work. And again, nice, it's great, but then you get vendor lock-in, right? So you get the situation where now your entire application revolves around the fact that you're using Firebase and Firestore. And then, it has costs attached to it. And you have to work around those, and we'll get into that. So, all right. I forgot to start my timer. I'll start now. Anyway, but why? Still, why would we do this? Why would we take on the task of building a real-time communication system? So here are some of the things that we were trying to solve, and I briefly covered some of those, but I'll go through some more detail. So Dart on the client and server. This allows your developers to work on both sides of that equation. There's a lot of problems that happens when you've got a team of people that say that TypeScript developers, and you've got some people that are Dart developers, and you have this kind of volleyball effect that happens. They create a ticket, you need to fix this on the API you need to fix this in the app, and back and forth and back and forth. Where if you had one developer that could just cross that boundary and do both sides, it makes sense. There's also this kind of aspect to this, which is if you can do Dart on the server side, well, you can run it locally, which means now you allow developers to easily debug and develop the entire platform locally on their machines. Yes, there is emulators and simulators with Firebase, but again, they're not exactly fun to work with. And again, they have their limitations. The project that we were building was a SaaS product. So there was this infrastructure model in place where they wanted to do hosting on premises as an offering. That completely denies any hosted solution like Firebase, so it was out the door immediately. But also equally, they wanted to cloud host it and cloud host multiple instances as a SaaS product. So in that situation, yeah, you have to do something yourself. How best do we do that? We'll get to it. One of the limitations that I found over the years we're using Firestore has been geospatial queries. Whenever you want to do geospatial queries, it kind of supports it, it kind of doesn't support it. It's kind of half broken. It doesn't officially support it in any of the documentation, but there are some models that you can use and do greater than, equal to, less than. Again, I'd like it to work. And then full text search. I'm pretty sure most of you, if you've tried to do search with Firestore, have found this a big problem. You end up having to do this lovely thing where you, on write of a document, in the client side, you take the maybe title description of the object, get rid of all the only keep the keywords, get rid of all the terminating stop words, like and, or, it, whatever, and then lowercase it all, make an array, and submit that with your document as the keywords. And then you can do an array with Firestore to find them. Again, the data changes, you have to update that. You're essentially working around the limitations of the platform. Can we just have full text search that works and works across multilingual boundaries? Anyway. And then again, sort of data storage. AI is such a big thing nowadays, as you've all heard, and I've had to mention it just once in the talk. But when you're trying to work with data that you want AI to work with, it's better to store it in a vector database format. Again, Firestore doesn't support it out of the box. So again, we need to find another solution. And finally, I did mention this, but simplifying the implementation, that control and having control over the data delivery pipeline. So about how we transmit and receive data and having full control over that was quite important for the project. So let's see where we go from here. So now you understand sort of some of the reasons. Where does one start on this journey? Which tools should we use? We'll get started on the database layer here. So the solution that we went for, after researching many different options, was Postgres, or also called PostgreSQL. Postgres is quite well known. It's long-lived open source project. It's been well tested. It's well used. I mean, you can trust it, right? That's quite important. I mean, it's fine to make one yourself, but then you're going to live with the consequences of doing that action. So, yeah, let's choose one that's good. It's ACID compliant, which is you need from any database, and it has full MVCC, multi-version concurrent control, something like that. Which basically meant that you don't get clashes on documents and locking and some other issues. I mean, I hear you all cry this word in your back of your head. I want to write, well-structured structured database queries, like the NoSQL is the future. I've heard of this. But you can achieve this with Postgres. So Postgres supports a document object store kind of model with JSON-B column types. This allows you to dump JSON into the database and query directly in your queries, access any one of the fields and values from in that JSON-B column. B for binary, it also is indexable. So you actually get some performance optimizations from that. You're not just passing JSON every request. And then the other side of this coin is I want to write structured database queries. So in that sense, you've got this notion of, I think all of you, if you've used Firestore, you maybe wanted to do something like, let's say you got a list of countries and how many people favorite that country. That's fine, but then you want to have the number of favorites per region. That's nothing you store in the document, so you have a separate document for analytics or something, and each time those documents change, you have to maybe write cloud function that updates the other document with the totals. I mean, yeah, it's crazy. Anyway, so yeah, what we want to do is support that. Well, funny enough, obviously Postgres is a SQL database. It's fully relational. You can do all your lovely queries for analytics to your heart's content, and even do a thing called generated columns, which means that as data changes, it updates the values for you, and you didn't have to write any code. Anyway, and then as mentioned, I came to this, but support for geospatial and vector queries. Postgres doesn't support this necessarily out of the box for default installation, but what you do is you activate or install PostGIS, which is the geospatial extension, and pgvector. Of course, we talk about limitations. There's tons and tons of extensions. It's a well-known project, Postgres. However, you could always write your own. So if you really wanted to go down that rabbit hole, you could do that. Flexible. Okay, a bit more on Postgres before we move on. One of the other key points to doing something like Firestore is to receive updates when data changes. So what you want to do is have like cloud functions listen to database changes and react to those. So Firebase, Postgres supports a thing called notify listen. These are just SQL statements that allow you to listen to a channel and deliver payloads on those channels in the future. There is also a streaming replication protocol that allows you to receive data as it changes, almost like a write-ahead log. If you treat that right, that can also be beneficial, especially if you're dealing with multiple servers, something we had to deal with, but I won't be talking about more today. But can I use Dart with Postgres? Well, yes, you can. There's a Postgres package on Hub, funny enough. And Istvan, the author, is brilliant. He's actually been rewriting the version 2 of Postgres into version 3 now. It's published, it's active. A lot of people use it, very well tested. And as I mentioned earlier, local execution and having that sort of work on the developer's machine. You can install Postgres directly on your machine if you want to, or you can run a Docker container, VM, Vagrant, name it the way you want to do it, but it will just work, right? And also you can deploy it to the cloud environment, so you can deploy it as your own instance on a compute engine if you wanted to. However, Google offered a hosted Postgres solution. So Google offer Cloud SQL, and that's in various different variants of SQL, and that includes Postgres. Google, was it Last I.O.? I think it was Last I.O. offered AlloyDB. It was a new product then, I think it was, yeah. And AlloyDB is a Postgres active API. On the back end, it doesn't use Postgres, it uses a different data storage mechanism. The great benefit of using AlloyDB is it scales horizontally instead of vertically. So Cloud SQL, you give it more machine power, more memory, more CPU. As your database grows, have to start doing sharding and read replicas eventually. But with AlloyDB, you just don't even have to worry about any of that stuff. It scales horizontally for you, it shards, it directs the connections to the right portion of the database that needs it. It's really quite nice. And of course, if you're not a Google person, well, you've got Amazon RDS that also supports Postgres. And as I said, you can just start up any basic VM with Postgres. So you're pretty flexible. Okay, so I kind of alluded to this, but I hear you all probably thinking that Firebase with Firestore is not just a database, right? So you can't just choose Postgres and have that work for you. So we need to address the other parts of the problem. So I'm going to cover a bit about cloud functions. So pretty much any Firestore database that you implement, you're going to need to use cloud functions at some point. This is just like, I gave that example earlier, but like listening to a document, updating other documents to reduce the number of reads and writes to the database, to bring down your costs. I mean, if you don't do that kind of thing, you start getting very popular with more users on your platform. Something gets really out of control very quickly. I've seen clients with bills of $5,000 to $10,000 per month in Firestore. There's no joke. But you know, and you've also probably, I'm talking a bit over this because I didn't get to write enough slides, but you also want to protect your Firestore database normally, right? So you write those complex Firestore rules. Again, I'm not dumping on Firestore, it has its place, but when your project gets large enough, it's no longer fit for purpose. So then it's really difficult to reason through those Firestore rules sometimes. You only have Boolean algebra to work with. You can't write, any arbitrary code. They're difficult to test. It's fine for simple use cases, but as your project gets more complicated, you grow out of it very quickly. And here the big problem, as I mentioned earlier, is that you can't write them in dark code, right? Not at least without compiling to JavaScript and dealing with crazy debugging things that it'd not be worth doing. So what do we do from here? So Dart on the server has been a topic for a little while now. There's many different solutions. RESTful APIs are the way to go with most of this. So transactional APIs, so RESTful APIs are transactional APIs over HTTP driven by the client. I say driven by the client, you're not doing push, right? So it has to be action from a client first to then get the response. However, it solves a problem. When you want to do those APIs and remove cloud functions from the mix, you can replace it with your own APIs. There's a first-party package called Shelf. If you haven't heard of it, check it out, and Shelf Router. These are made by the Dart team and offer a solution to having a wrapper, a nice wrapper around the basic HTTP server that's built into Dart.io. I believe there's also support for HTTP2 in there as well. It's kind of hidden, but there is also client as well as server. There is a server version of HTTP2. I did find it the other day. And then, most of the time, you can just simply write APIs to do your create, read, update, delete. It's pretty straightforward. The standard CRUD operations are pretty much what you want to do to just replicate the Firestore system of managing documents. And there are alternatives to using like Shelf and some of this other stuff. So you've got Dart Frog and Serverpod, and also the functions framework. So all these are different efforts, and I know the Serverpod guys are here, and they've also been working on real-time communication with Serverpod. So they have a talk tomorrow. So if you haven't got your schedule and you're interested, go check it out tomorrow. Okay. So I kind of wanted just to kind of show a little bit of code, at least. For those that haven't used Shelf, you get some basic sort of, this is a Shelf router specifically along with Shelf. But the idea is you have handlers for each one of your requests to deal with the request and send back a response. They can be asynchronous. In this case, this set up a pipeline which builds a handler that manages this sort of structure. What we're seeing here, I'll just walk through it briefly. That is, it logs the request coming in. We add some exception handling middleware. So if there's an exception thrown further up in the stack, it will return back nice like JSON error structure. We mount the WebSocket handler. This allows us to handle WebSockets. We'll get to that in a minute. You can also use Shelf Static. That's a package that allows you to host static files off of Shelf. If you've got any sort of data that you need to send back that is not changing, great way to do it, like images, whatever it might be. You have something like an auth API that's outside of your authentication pipeline, and then you have maybe an API, like in this case API users, protected by some auth middleware that would then check the headers to make sure it's secure. This example does exist. It's called Wow Shopping. It's on my GitHub if anyone's interested. Deploying. So you build your RESTful API, you do your handlers, you've done your work, great. And you can even use the Postgres package to read and write stuff from the database. This is still not real-time communication, but we're getting there. Deploying to the cloud. So when you've got your Dart, when you use the Dart template, so Dart create -t server, it will create a shelf template with a Docker file attached to that. That enables you to build an image which contains a version of your application. So if you're using, I try and sort of break this down a little bit. So you have runtimes, right? So if you need to deploy, say, some Python code to the cloud, you're going to deploy it with a Python runtime environment. This is going to have the Python interpreting engine and all the libraries associated to it. And then you add your Python script on top and then deploy it. That Python environment might depend on operating system requirements and some other things. So you end up deploying maybe 300 megabyte image, maybe 500 megabyte image or something ridiculous. The nice thing about doing it in Dart is you can actually deploy your Docker images from the scratch build, which basically means nothing. And nicely, the Dart team have actually supplied a base set of files that get shipped in to your image, which does enough to do things like DNS resolution and some other things to make the Dart environment work. So what's really nice about this is it means that your deployments, when you're deploying Dart on the server side, is going to be about 8 megabytes probably for your basic thing, upwards of maybe 20 megabytes for something high level. It's really quite optimal. So back to this. You can deploy with really simple commands with gcloud to Google Cloud Run. There's also Google Kubernetes Engine. Google's Kubernetes Engine is basically the platform that is underneath Cloud Run. So this is the thing that actually is going to host all those, all your scripts that are running and so on and so forth. It is, however, a lot more complicated to run, and you need to understand Kubernetes and pods and deployments and all sorts of other terminology. So if it's your first time, probably stick with Cloud Run until you've got time to learn it. It has benefits, especially if you need to scale stuff and move stuff across different zones around the world and all that kind of fun things. So it's where you want to kind of go. Kubernetes Engine is also something that is cross-cloud. So if you build to Kubernetes Engine with if you have DevOps teams, they will know about this, but use infrastructure as code. You can then start doing deployments across those sort of multiple boundaries and have things like backups in AWS compared to Google Cloud and all the fun things. I will just briefly talk about some scaling things here. So Cloud Run will scale, and you can set up your scaling requirements. It will also host WebSockets, and it will host HTTP2 connections, and we'll get to that in just a minute. Right. So two-way communication, we're getting to it. So the crux of sending and receiving real-time updates. So there's many different solutions, and I think the one that we chose to use was WebSockets. So I mentioned this before, but HTTP transactions, HTTP requests are transactional. You take a request and you get a response. WebSockets, not so much. WebSockets have some other benefits. WebSockets are full duplex connections. So you can send and receive data at the same time, back and forth, not a problem. And interestingly, WebSockets are also the standard HTTP requests that get upgraded to WebSocket connections. And basically this just tells the web server to just ignore the connection after this, right? It says, I'm handing it off. I'm not going to close the socket. I'm not going to do anything with the socket. It's now the application's responsibility, not the web server's responsibility to manage the connection anymore. This is also called connection hijacking in Shelf specifically. This has many benefits. We'll cover it in a bit, but if you make a normal socket, so first of all, communication is done over sockets with the internet, and that communication, you connect with ports. So you have a host IP or host name that you're trying to connect to, and a port you're trying to connect to. Hopefully you've all seen this. There are limitations around those ports, and a lot of corporations and internet providers will block certain ports, right? And especially in ranges they have no idea about. Like, it's quite common. HTTP and HTTPS are quite commonplace now, so they don't block them. So the benefit of having a WebSocket that upgrades is that you can have that two-way communication, but not get blocked by firewalls. And more specifically, you can use WebSockets on web. So if you've got your product you're trying to deploy to web, you can now build a website or web app with Dart or Flutter Web and actually have it work with real-time communication. And luckily for us, there's some packages made. So there's some first-party packages made. So WebSocket channel and Shelf WebSocket. So WebSocket channel is the underlying implementation using Dart.io, and then Shelf WebSocket is the package that joins Shelf and that underlying package together. However, it has its limitations. You can work around them. However, WebSocket client was written by Felix, and I don't know if you know who Felix is. I'm sure all of you have heard of Block. Well, he's the guy who came up with the official Block package. Anyway, WebSocket client is a great sort of alternative. Okay. A little bit more on this. You can monitor and know which of your users are online and offline by just keeping track of the WebSocket channels on your server side. And if the channel's been closed, you know the user's gone offline, the connection's disconnected. WebSockets, by default, have a protocol attached to them to keep the connection alive. It's a ping-pong style protocol. You can set up what your timeout is and things. But that will ensure, basically, if someone's traveling around with the app, the connection persists, you can still send data. And this also means that you do that online-offline tracking on the server side, that you can then know if a user's online, that you send the data to them directly. I'll cover this here. Yeah, I'll cover this here. So I don't know if any of you have experienced this problem. I certainly have, where you want to send a push notification. You want someone to get an instant notification about some data, right? Or some change in your product. So you send a push notification. You don't know if the user's using your app or not, so you just send a push notification. It takes maybe 20 minutes to get there. Maybe even their phone's on low battery, it takes even longer to get there because it checks only so often. These are problems, right? So by having the WebSocket open and having the online sort of channel to them, you can know on the server side if you're connected to that user and deliver it directly down to the channel, straight to them on their device. Even if you've got 5 devices open, there's 5 channels, you send it to all 5 channels, bing, 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 they get on all of them. No push involved. However, what's great is when it's offline, well, you can also send them a push notification then. And then that push notification could be a data push. You wake up the device in the background, you run your Dart code in the background with Firebase messaging and process whatever you need to process about the transaction, connect to the server and so on. WebSockets on GCP specifically, found this out quite recently, have a maximum life of 24 hours before they must be reconnected. They'll just shut off. I'm not sure the underlying mechanism to this right now, but it could just due to the settings on things like Cloud Run and such like, where they'll only keep instances alive for so long before they restart them. You can have other scanning things like after 500 connections or 5,000 connections, it'll just shut down the server and restart it, and it'll start up another one before that happens. Anyway, this allows you to get away with memory leaks. It's quite commonplace to maybe have those things. So if you just restart your server every number of connections it handles, then the memory leaks aren't a problem anymore. It's kind of a cop-out, but anyway. Ephemeral ports. I'm guessing no one's heard of this. It's a topic that only is covered by using WebSockets, really, with online stuff. So I did allude to this, but the limit of TCP and the way internet works, there's a limit on the number of ports available to each host. That's 65,535, which is the maximum value of a 16-bit number. This is just because of the way the protocol was set up originally. And since each connection needs a unique port number, and you need some reserved by the operating system, and it'll use some generally for doing other things, you probably around 50K. You could probably get away with 50K connections per host. I mean, you've got to have a pretty big host to actually be capable of handling 50,000 requests, but it can be a problem, especially if you've got maybe one front-end host that's being connected to, and it fans out to many. There are solutions to this. They're well known, but the keywords you're looking for are ephemeral ports if you want to look them up online. To be clear, this is the number of concurrent connections one host can actually handle at any one time. So yeah, I mean, you've got to have a pretty popular app to actually come to this problem in the first place, and then to solve it, there's well-known solutions, and so just want to make it clear that this is a thing. Okay, sending and receiving data. So data being sent over WebSockets are basically message orientated, so packets going back and forth. You can send them in both directions, as I alluded to, and the idea is that you choose your own format. It just sends it over as binary data, and then you choose however you want to interpret that data. There are some, in the Dart libraries, it will do some nice things where if it's an integer, it handles an integer and string and so on and so forth. But for the most part, I think most people here are probably going to just be serializing JSON, sending it back and forth. It's perfectly fine. You can even take JSON RPC, put that on top. Now you've got yourself an RPC, simple RPC mechanism. Or you could just use serverpod. Anyway, so the model that we sort of alluded to that we were trying to build is a subscription-based model. So what we wanted to do was notice when data changes. So the user subscribes to some sort of data, they get back an ID, and when data comes down that socket, it's attached to that ID, so they know what the data was updating. And then obviously you can unsubscribe from the data as well. There's also data synchronization. So although strictly speaking, it's not supported by all the stuff I've been doing so far, you can do data synchronization. It is a known problem, and there are solutions. So CRTD, conflict-free replicated data type, is a data structure that allows multiple replicas to be updated independently and concurrently without the need of synchronization. So this is that kind of trying to solve those kind of problems that, I mean, I'm sure we've all had merge conflicts when committing code. It's that kind of thing. How can you solve these kind of things? So there are on Pub, there are two great packages, CRTD Sync and Postgres CRTD. They're actually by the same author, Daniel, and they work together. So I haven't implemented this yet, but I do want to. I did allude to this, but there are alternatives to WebSockets. gRPC, I'm hoping some of you have heard of gRPC. It was originally called Google RPC, and then Google changed it to General RPC. I wonder why. Basically using normal sockets to communicate over a binary protocol using protobufers. So there's some learning challenges there, right? So one is, as I said, some problem maybe with firewalls and some other things you can get into with that. It's great for internal traffic through infrastructure. And of course, with the binary protocol, it's not so easy to examine and debug and handle and manage. It is more efficient. So the reason why Google, I'm sure, have implemented it, I don't know, but the reason why I'm sure they've implemented it was a lot of their internal APIs use gRPC, and it was a great way for them to optimize their traffic and manage their API internally. So in that sense, is it good for an app? Probably not. You could make it work. We'll see. Anyway, and then there's also HTTP 2 and 3. Those of you that thought there was just 1.1, there's more versions. So HTTP 2 does enable two-way streaming of data. The protocol is a streaming binary data protocol now. It's no longer a text-based protocol from HTTP 1. But again, it has its limitations. So it must be client initiated. So there must be at least a request to get responses back. And server push, which is the mechanism that is displayed here, at least in the picture, is this notion that you make one request and you can send multiple pieces of data back. You can hold that open and continue sending data back, and this way simulate a kind of real-time connection, but it's in one direction, right? It's not really in two directions, right, over the same connection. So you could make other RESTful requests to then initiate data coming down the other pipe. It just becomes kind of awkward to manage when you've got WebSockets that do the same thing and it works. So yeah, as I said, it's primarily used for web purposes to pre-cache content instead of being multiple requests and responses to get the same data. HTTP3 is HTTP2, but over UDP instead of TCP. There's always been an issue with multiplexing connections and what's called head-of-line blocking. This has existed in HTTP and HTTP2 for a long time. Briefly want to explain this just because it's good information to know. You make a multiple request to the server down one connection. The server has to send back the data for the first request before sending data back for the second and third request because they come in order. That is HTTP 1. 2 kind of solves this with multiple streams on the same connection, which is nice. However, you still get a problem. It's TCP, which it kind of means that the whole retry mechanism is out of control of the API. So with HTTP 3, they kind of narrowed that scope and meant that with UDP, they can control the flow of data better and therefore completely remove head-of-line blocking as an issue with the protocol. So eventually we all want to be shifting to it, but yeah, eventually, right? Okay. So end-to-end data access. We've spoken about databases, we've spoken about APIs, we've spoken about communication. How do we bring them together? I want to make this section a bit longer than what it is, but I'm going to briefly go through what kind of some of the sort of snippets of what we've done, and I'll cover it a bit more in a minute. So with the Postgres package, you get this Postgres SQL connection. There's an extension that sits on top of the connection, just adds some functions that give these three SQL statements some APIs that you can functions that you can run. So listen on a particular channel. That channel name is like a unique ID. Unlisten, put enough, stop listening on that same channel that you previously listened on, and then notify. And then this is so listen, unlisten is what you might do on the client side of the database connection, and then you've maybe got two servers or two units of work running. When that data is changed, you can then say notify that channel that the data's changed and give it a payload. That payload can be like a JSON blob. There are some limitations to doing this. Those are things that we ran into. The payload size is limited to 8 kilobytes. So what you might end up doing is notifying just with an ID and then going to retrieve the data from the database. That has benefits and problems aside. To be clear, this is database monitoring on the server side. This is not on the app. This is you running this on the server side so you can work with the database. So you've got a connection coming in, it modifies some data, or an admin goes in and changes the data in the database, or you've got some external APIs change the data in the database. The eventual goal is the source of truth comes from the database. And then you can set up triggers on the database to call notify, and notify then tells the listening server instances that the data's changed. It's a simple mechanism and is very effective. So when it comes to Postgres itself, each of your it's the server code might be listening to the notifications channel off of the Postgres client API package, and then you can look at that channel name. Is it the channel name you previously registered? Obviously, basic example, but you'll probably have like a set of registered channels and so on, and then you can decode that data that you're getting back, process that data, iterate through your WebSocket channels, and find matching clients that want that data. And then something that I'll tell you now, something that we ran into was the database might restart on you, or you've got to upgrade the memory on the server and it restarts the database. So I see at least what you want to be doing with long-running server instances like this, you want a temporary connection if the server's not shutting down on purpose, basically. And then, yeah, you just listen to a particular channel. So I wanted to go through a demo, and I'm afraid I didn't have enough time. But if you want to, that QR code links to the GitHub repo that's on the screen. Or if you want to grab the GitHub repo, after the conference, after the weekend, I will publish the code that does all the stuff that I'm talking about now, and then you guys can pick it up and examine and play with it. The image, the video that's showing was actually done by Joachim or Wolf. Maybe some of you know him on Twitter and so on. We're trying to work on this animation, and what I wanted to do, which I found in time for the conference, I'm afraid, but that was to have you all join the app, pick your country of origin, and then you'd all come up on the screen as flags in bubbles, and then the bubbles would get bigger the more people from one country or the other, and it'd all be real time. And that's what the demo will show at the end of the weekend. It just wasn't finished in time for now. So coming soon, TM. In fact, on this point, we had a cancellation scheduled today at 5:20 in Dart Den. I will be doing a workshop and I'll continue the work on this. So if anyone's interested in real-time communication going a bit further, understanding how you do the database listing and so on, I'll actually be doing that in the room, live coding it, and you can all join in and try yourselves. That's today at 5:20. Okay, the future. So I did mention this and allude to this, but not just doing this demo project, but I really think that this could be quite a nice package. Not a package that you drop in like, here's server pod, it's gonna do all my stuff for me. What I want to do is, here's some components that you can use to implement in your own backends to achieve these things so you don't have to do it all over. And then we can also all contribute to that. And if there's any bugs, we can all benefit from it, right? So what I want to be doing is, and what will be happening is an open source package will be published hopefully soon, depending on schedule, but definitely within the next 6 months, which will cover all this stuff in a more formal manner. I did also mention about push notifications. It'd be nice to get that in there as well, so that automatic online, offline monitoring and using push notifications when people are offline. It's quite a nice feature to have out the box. Okay, that's it. That's what I've got time for. Hopefully I've imparted some knowledge. As I said, the GitHub is here. It's not published yet, so it's all going to be 404 right now. But it will be there by end of Sunday evening. I've got the conference to finish off first. So thanks very much. And I think I might have time for questions. I forgot my timer, so yeah.